The Earth is not a perfect sphere, but an oblate spheroid or geoid, slightly flattened at the poles and bulging at the equator due to its rotation. This shape affects gravity, making it slightly stronger at the poles than at the equator, which in turn influences ocean currents and the movement of tectonic plates. The equatorial diameter is about 12,756 kilometers, and the polar diameter is about 12,714 kilometers, showing that Earth is wider at the middle. The interior of the Earth consists of three main layers: the crust, mantle, and core. The crust forms the rigid outer layer, which is broken into tectonic plates that float on the semi-molten upper mantle, known as. This movement of plates is driven by convection currents in the mantle and is responsible for most geological events, including earthquakes, volcanoes, and the creation of mountains. The core, with its liquid outer layer and solid inner layer, generates the Earth's magnetic field, which interacts with solar winds and plays a role in protecting life on the surface. The concept of plate tectonics is closely connected to earthquakes. When tectonic plates collide, slide past, or pull apart, stress builds up in the Earth's crust. When this stress is released, it causes an earthquake. The focus of an earthquake lies within the crust or upper mantle, and the epicenter is directly above it on the surface. Earthquakes are most common along plate boundaries, such as the Pacific Ring of Fire and the Himalayan belt. The same tectonic movements also form mountains and trenches, which shape the Earth's surface and influence climate patterns by affecting wind and rainfall distribution. To locate these features precisely, geographers use latitudes and longitudes, a global grid system. Latitude lines measure distance north and south of the equator, while longitude lines measure distance east and west from the prime meridian. The positioning of mountains, earthquake zones, and ocean trenches can all be described using this system. Latitude also determines solar angles, which influence climate zones, seasons, and even phenomena such as solstices and equinoxes. The tilt of Earth's axis at 23.5 not only causes solstices and equinoxes, but also affects tides and ocean currents. During solstices, one hemisphere receives more direct sunlight, heating the oceans unevenly and causing circulation patterns that distribute heat around the planet. Tides themselves, caused mainly by the gravitational pull of the moon and the sun, are influenced by Earth's rotation and its equatorial bulge. Spring tides occur when the sun, moon, and Earth are aligned, while neap tides occur when the sun and moon are at right angles, showing how celestial movements interact with our planet's rotation and tilt. Eclipses are another example of celestial alignment impacting Earth. A solar eclipse occurs when the moon blocks the sun, and a lunar eclipse occurs when Earth blocks sunlight from reaching the moon. The timing and visibility of eclipses are connected to the same orbital mechanics that govern tides, seasons, and the solar angles that define the Earth's heat zones. The heat zones, the Torrid zone, Temperate zones, and Frigid zones are influenced by latitude, the tilt of the axis, and Earth's rotation. The tropic regions receive the most direct sunlight, explaining their high temperatures, while polar regions receive very little sunlight, remaining frigid. These zones also influence ocean currents, wind patterns, and even the formation of deserts, linking climate directly to the structure and movement of the Earth. In summary, the shape of the Earth, its interior layers, tectonic activity, orbital tilt, and celestial interactions are all interconnected. Earthquakes shape landforms, which influence climate and ocean patterns. The axial tilt creates seasons, which affect heat, distribution, and tides. And celestial alignments govern eclipses, while also subtly affecting tides and light exposure. Understanding these connections helps us see Earth as a dynamic system, where geology, astronomy, and climate continuously interact.